Thank you for the introduction. Okay, hello everyone. I am Baris, a fourth-year PhD student in computer science at the University of Minnesota. I'm working with Professor Lana Yarosh and studying video-mediated communication in SIGCHI. So we did this study last year in Microsoft Research. I was an intern. I did with Tang, Gina, Venolia, and Kori, Inkpen, and my two colleague intern friends helped me on the study. And so what if we have a mobile phone and built-in camera and the internet access? So we live stream as normal people. And can you live stream without using your hands? So this was our motivation and question. And there are some solutions out there like this, or maybe this. And it's too early if you watch the Black Mirror. And our assumptions are we have infrastructure cameras everywhere. So if we can control them and if we can collect that all streams and create another interesting experience, is it possible or not? We try to implement it. So the related work says people use live streaming for communication, collaboration, sharing the experience, personal branding, and making money, and just for fun. And there are lots of applications that you can use for this purpose. But there are some limitations and problems. Traditional systems face these limitations. One hand always occupied. You know, you have to look at the screen. It's distracting, demanding, and bandwidth, latency, video quality, battery, heat, and other problems. And also viewers suffering from those problems as well. And so if we use infrastructure cameras, we are solving most of these problems. They always have wired internet access, and they are plugged. So the problem is how can we collaborate this in a rhythm? So our research questions: should remote viewers have the autonomy to choose an independent stream? And in what ways would the lack of shared visual context be a problem, or disruptive, or helpful? How would the local users' lack of awareness affect our experience? So I'll be talking mostly about the user study side. So we built a system. We used some web cameras and Raspberry Pis. We created some units. So one unit is consisting of two cameras, a test camera and a face camera. So that we call this as a unit, and we used 5 units and a wide-angle lens attached room camera. So here are the locations and positions of the cameras. So here there's a wide-angle room camera looking at this direction. And we had a table, and we have 5 task spaces, which is marked, labeled with colors. So this is the system architecture. So all the cams goes to FFmpeg, and then it pushes the walls of a media server, and then to the web browser, and it dispatches to the viewers. And we tried to implement some Python and OpenCV web face tracking, but we were unsuccessful because of the light and the angle of the view. So we implemented a Wizard of Oz approach. I'll tell it about later. So how did we investigate? We designed a user study to explore our system. So we used 3 conditions. The first one is the base handheld mobile phone condition, and the second and third ones are hands-free modes. One with manual condition, and the second one is the auto condition. So this is the room view. We have some hotspots. If you click these hotspots, you can switch to this task view camera anytime. And here is a view from task view and a view from face view camera. So you can use this user interface in a hands-free manual condition. So how did we measure, and what did we measure? We recruited 54 people, and the average was 21 years old, and there were 18 groups of 3. And the task was a collaborative memory game. We used 3 different sets of pairs and fishes, butterflies, and flowers. So we we welcomed and informed the participants, and they practiced before studying. And we assigned some users to local and some users to remote users. And they completed a post-game surveys and end-of-study survey, and we did a semi-structured interview at the end of all conditions. So these are the data we have collected. So the limitations, so it was a lab study, so it's supposed to be a real-life study, open space, but it is very difficult to find such a space which full of cameras and control that space. So we had to do a lab study, but we are planning a study in the wild. So participants, they don't represent the general public because we recruited all the participants from the Microsoft research. They were interns at that moment. So the first condition, handheld mobile phone condition, I have some short videos, so we can watch them and see. I think we can hear the Okay, so this is handheld condition. So you can see that it's drizzling, and we have to be attached to the streamer's wheel, and the streamer is walking around inside the lab and trying to find the pairs and the cards, and viewers are trying to help the streamer. This is the handheld condition again, and from the view of viewer B. The same thing. The hands-free manual condition. So you can see the viewer A on the left side and viewer B on the right side. They have the same, they have different views because it's a manual condition. So they can switch any camera as they want. So it's giving us some sort of freedom. And the auto condition. Again, viewer A and B, but only one view. They have no control on the views. You can see how relaxed, so they don't have to manage anything. So for the hands-free auto condition, we used a visible false approach. We trained a person, and that person tried to follow the streamer inside the room. So let's switch to results and our discussions. So after completing the 3 game sessions, participants ranked the conditions by preference. This charts belong to streamers, and streamers ranked the automatic condition significantly higher than both manual and handheld condition. And streamers also ranked in the preference. Also, streamers ranked the automatic condition significantly higher than the handheld condition in ease of in ability to communicate and best sense of room. And these are belong to the viewers. If we check the performance, there were no significant difference between each condition. And we noticed that there is a learning effect, but we counterbalanced each condition, so it didn't affect our study. The interviews, we got lots of insights and we learned lots from the interviews. So I want to cite them. Consistent with prior work, we see that remote collaboration using a handheld setup is cumbersome for the user streaming the video. Participants reported that holding the phone up for extended periods of time was tiresome and caused them to alter their experience. Furthermore, streamers reported that it was difficult to remember to adjust the view appropriately while performing the task. This often led to poor viewing angles for the remote viewers. From the viewer's perspective, the handheld condition was preferred the least. Viewers reported that due to the natural movements, the handheld condition was less stable and difficult to attend to. Furthermore, viewers lost perspective of the room and were limited to the field of view provided by the streamer. However, an advantage of the handheld condition was that it provided everyone with a shared view. The streamer reported that knowing what the viewers were looking was helpful for coordination and communication. And for the hands-free conditions, in the automatic condition, streamers were informed that the viewpoint would be selected to follow them. Streamers reported that knowing that the viewers were following them made them feel like the reviewers were with them at all times, which made it easier to communicate. In the manual condition, streamers had limited awareness of what the viewers were attending to. The opportunity for viewers to select alternative views left the streamers confused about what the remote user was looking at. And they often claimed that they had to use more effort to communicate. However, some groups used the ability to look at multiple places at once to divide the work and multitask. The viewers had equal preference for the manual and the automatic conditions. They expressed benefits to each of them. One participant made the following comparison. I liked it very well. You know, I think it's summarizing. We saw this type of comparison with most groups. Many viewers who preferred automatic condition felt that it was easier to attend to and required less work. In contrast, viewers who preferred the manual condition enjoyed the freedom to navigate the room independent of the streamer and the opportunity to multitask. Furthermore, all viewers reported that the manual condition gave them a better sense of the room. So we also analyzed the videos, and users had 3 separate views from the left space and switched among them during the task. Viewers used the task view most, followed by the room view. We also provided face view, but we see limited use of the face camera, likely due to the structure of the task. Participants reported some explanatory use of the face camera, but they claimed it was not useful. In addition to the recording viewer actions during the manual mode, we also simulated the automatic condition for a comparative baseline. We compared the differences between the 2 viewers in a session and between the viewers and the voice condition in a session by measuring the amount of the time they spent in the same view. The results show that there is a significant amount of diversity between remote viewers and also between viewers and the voice. In the manual condition, we found that different groups used different strategies to complete the task. For example, some groups used the manual condition to support multitasking by having the remote viewers look at different task spaces than the streamer. Viewers were also able to navigate to the upcoming task space before the streamer. In this work, we investigated opportunities for hands-free remote collaboration over video systems compared to traditional method. We see that hands-free condition is just as effective as the handheld condition. Here is a summary of our findings and comparison. However, results this work reveal that the design of viewing experiences for hands-free video conferencing still needs further investigations. So for the future directions, so we found that both automated manual and hands-free manual and hands-free automated conditions have their pros and cons. So we imagine a semi-automatic system to combine benefits of both systems. And we are planning a real-life study in a real outdoor place. So here are the takeaways. We developed a novel hands-free multi-camera system to support sharing experiences over video. Our study found the hands-free condition was just effective as the handheld condition. Both streamers and viewers preferred the hands-free remote collaboration system despite its limitations. Furthermore, the automatic hands-free condition provided more shared context between the streamer and viewers, which contributed to more seamless communication. Thank you.
Thank you, Baris. So, are there questions? And while you are thinking about, I start with a question.
Sure.
I did not, to be honest, I did not quite understand the rationale behind it. So what kind of applications are you really looking at? I mean, typically you don't play collaborative memory games, right. But at which point would it be useful to use such a system? Maybe you can clarify that a little bit more.
Sure, thank you. So you can imagine you're in a Disneyland or a controlled space. You're having fun, but you have to use your mobile phone and to share your experience with your friends and family. They are not with you at the space. So, but this is limiting your experience. So how can you get rid of from using this? So, okay, this is a controlled space. We have the control of all cameras. We can get all the streams, and we can track you. We know your face. We can track you, and we can narrate the scene instead of you. Yeah, this is a kind of example scenario.
Yeah, but this, of course, would need a lot of equipment in a room. And so I did not really get the link between your motivation, which actually says, if we have video surveillance everywhere, we could just use it for such purposes. So this is my take on that, so maybe I'm wrong. So I don't understand it, because in particular, since I, as a particular user, have no chance to get all the video information from all the cameras, right, which might be from different purposes, like this is a police part, and this is a private part, and this is a Disney part of the camera. So So how do I use that? How do you? What's your idea on that?
We will see in the future. It's too easy to talk about it, I guess. Too early, yeah.
No, it's never too early to talk about privacy. Never.
Yeah, for the privacy, I mean,
you should talk about it as early as possible.
If you're okay, if you accept that you're filming, they are filming you at space, that's okay. But I am sharing the privacy concerns with you.
But how do you access all the other viewers, the remote viewers? How do they access all the surveillance cameras?
We have to provide a system. So that's what we did. We have to provide a system that we are assuming that we have the access. Mm-hmm. Yeah.
Good. Are there more questions beside my critical questions? All right. So if not, so let's thank all our speakers again.